So I'm probably a weird topic today, probably a little bit of ambiguity in that title. So what I'm here to talk about is how do you migrate someone like the intelligence and defense community to something like Amazon, which doesn't sound hard, really, but it's actually quite complicated. And what I'm going to talk about is a story about over the past year, we've been working with a couple different agencies on how do you tackle taking a bunch of legacy applications and analytics and services and migrate them rapidly to an entirely new environment, an entirely new way of thinking about managing your IT infrastructure. And then how do you do that as we're moving towards this never-ending progress towards new technologies, new frameworks. Every day I hear about a new cool framework, and every single engineer in this environment wants to play with that, but they're not secure. And security, there's many different levels of security, but how do we deal with that issue, right? So that's what we're going to be talking about today, and it's talking about a platform that we built to help speed the migration on top of Amazon. Because it was very new and novel to us to be able to deal with this in the enterprise. But the first thing I'm going to talk about is a little history of the problem that we face in the government. Because I don't think a lot of people really understand the pain that we felt during the past, since 2001 we've been at war. And everything really changed in 2006. And most people don't realize there was a very key day. I remember being in Baghdad, and I'm a former Army officer, just a nerdy Army officer. And I remember being there, and I remember seeing all of a sudden something clicked. And it was Nokia N95s, media. People could start taking pictures with their phones. There were, now all of a sudden, these people could take video cameras and immediately start throwing that onto and sharing those videos out. We had propaganda everywhere. We had sensors. I had sensors on my trucks to find out where a bullet was coming from. I had UAVs that were passing me imagery in real time directly to my vehicle. Shoot, I even had like a little handheld that I could see as I was running to see if we had squirters coming out of the house so I could shift my cordon to go capture those people. And this was all happening in real time, but all this data was just sitting there. And our most powerful tool at the time was people. That's the beauty of being in the government, right? I can just order my soldiers to just not sleep for a couple days. And they would tag stuff up, right? So the best thing I had was we'd write a little Word document, hey, bad guy said such and such, might want to go raid this house. And then what I would do is I'd send my soldiers, and they would literally highlight in Word, and then they would create a folder, and they would drop it by the guy's name, and then drop it in the folder. And then I wrote just a script that would pick it up, and then look at clusters of, hey, as soon as I had 5 documents on a person, all of a sudden I'm more interested. And that was how we did it. It is not sexy. It's not Jack Bauer. There's no unlimited satchel with all the ammo in there. I'm sorry, it doesn't exist. I really wish it did. But that was the problem we faced. So all of a sudden, 2006, 2007, go to 2007, and there was a surge of apps. Like the government was dropping money like it was nothing. We were just printing money. And we were giving it to anyone who could build a cool app that could maybe answer some questions. Where are IEDs? Where are bad guys? Where are good guys? Keep in mind, the military is not a lethal force. It's also a non-lethal force. How do we inject capital into the market in order to stabilize a region, right? What is going on? Who are they electing? These are all the problems we were trying to deal with. So hundreds, thousands of apps started to just flood the market. And everyone did it their own way. And everyone that had a business wanted to make money off that, right? So, all the biggies are in here. So the Oracles, the SAPs, the Microsoft, now Amazon. It was just a myriad of technologies. And what we dealt with was, oh crap, now let's speed this up. 2011, how do we now rein this back in? There's some great applications. There's a lot of great data out there, but they're all stovepiped. And then anyone who's dealt with SOA knows, all right, now I'm like managing my ICD. As I, change something, now 200 other applications have to change it. And it's impossible to manage in the enterprise. Now let's speed up to sequestration. And now all of a sudden I'm a CIO or CTO of an agency, and my budget just got slashed 40% because IT is not the coolest thing out there. I want to go buy more planes. That's cool. So now I've got a budget issue. I've got hundreds of applications. I've got thousands of active data sources, and I've got multiple networks because we ride on classified networks. And they are the weirdest things you could ever imagine. It's not like, hey, I set up an intranet. Hey, it's easy, right? No, it's a mess. There's people with 19 different domains of emails. And then also liaising with foreign countries. Now I've got NATO, which is 17 to 19 eyes, depending on which day of the week it is. I've got my other partners, which might be 5 eyes, so I've got 5 countries I've got to deal with. And I've got to be able to coordinate and federate across all of those. Oh, and then, by the way, I have 230 active 1,000 users daily that if it goes down, trust me, they're really loud. And generals tend to yell louder than everyone. And they tend to only be this tall. So somehow they just find you and yell at you. And it's a huge issue. It's insane. You're always reactionary. And then we get to a point of, in the government, we also have this unique problem, which is certification and accreditation. And anyone who's done anything in the government knows they get really sad when they hear those words. And it's so hard. It shouldn't be that hard. But it's so hard to sit down with someone that is a security engineer and try to explain to them how Hadoop works, or try to explain to them, hey, I'd like to use Node.js. It's just JavaScript, trust me. But then they freak out when they start seeing how we're doing things. And then the larger issue at hand that we had to deal with up front was decisions were being made qualitatively. There was no data behind what applications are you transitioning, how are you transitioning them, do they really need 8 databases to support this single application? There was no data behind it. It was just, I think it works, so let's just do that. And oh, by the way, we'll just block off $20 million and pay for it this year, and because Congress will allow that. And so that was the problem we were handling. We were like, whoa, 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 well, we can't afford all this, and we've got to migrate this in a better way. And so budget was the killer. Most of the applications we're also finding were just CRUD-based applications. These aren't super sexy apps. What we found most people were doing, 90% of the applications we saw across this enterprise were, hey, I'm going to create a web form, and I'm going to enter some information. I'm going to insert it in there. I might need to update it. I need to keep lineage of, hey, this bad guy all of a sudden now I'm changing and saying I need to go back in there and say his real name is actually this. It's not, Abu Ahmed al-Kuwaiti. It's actually his brother Abrar. My bad. They look alike. And change it, update it, and then push that out so that way we can maintain lineage. Who did that? Why did they do it? Who did they have access to determine the value of that data? All those things had to be kept. But for the most part, they weren't highly complex applications. But we were finding on average, each application had at least 2 to 3 databases. And the worst part was each application was handling security in its own unique way. And that was actually what we found was the killer of time, was everyone thought that security meant something different to them. And when they went through these accreditation cycles, is that the problem was that the accreditors see hundreds of applications coming at them, all doing security differently. And so that's what slowed down the entire enterprise. That was the cog in the wheel. And so we had to remove that without pissing all the other application engineers off, because we were about to tell them, hey, we'd like to provide a standard of how you do security. And oh, by the way, we want to kind of cut down the amount of databases you're using. And oh, by the way, we want to apply other rules. So I didn't die, so that was good. They didn't kill me. But what we did realize up front was we had to think outside the box. And so I don't know if a lot of you know about Accumulo. So it came out of NSA, and we had been working on Accumulo for some time, and the problem we had there was actually much easier. We had a lot of data. It was wicked fast data, very transactional, and we knew we needed to secure it. And we knew if we could because we're all looking at very similar data there, if we could just house it in a similar fashion, we could then allow people to be able to access the data in a common method. And so that's what Accumulo is good for. But what we found out is that going to environments where you have a myriad of applications doing many different things with many different types of data, everything from PowerPoints, Excel spreadsheets, to structured metadata that's coming in at a classified number but greater than a petabyte a day, and you're having to analyze this and bring it all together, well, just shoving it in a big data lake is not going to work. And then trying to, now let's restructure our thought a bit. Now all of a sudden you're telling me, let's get on Amazon. What does that mean, right? No one knew how to deal with that. I've got on-prem, like I've got my own hardware. Everyone was, shoot, I've been to Afghanistan lugging my own hardware and shoving it in, plugging it in, and pray that the power doesn't go out, right? That's how we did it. That was how we did it with thousands upon thousands of machines. So now, all of a sudden, now I'm hosting it somewhere? What is that? How do I do that? Like, what's the process? And so what we realized was we had to get application engineers out of the game of infrastructure, out of the game of DevOps, out of the game of security, and focus on the business logic around their applications to get it in front of users. We had to lean their teams down. These were bloated teams. The average team size was about 20 people, believe it or not. And that's not good. That's how you actually fail, right? So, because they had to add security engineers, they had DevOps, they had program managers, they had people writing technical documentation. And so it was unmanageable. They couldn't get actual short-term deliverables. They became waterfall because they wanted to be agile, but they had to become waterfall because of their size. And the government supported that. The government was an enabler of that because that was what the government understood. And that was only the way they could maintain the timelines and deliverables as part of the contracts. But Amazon, with the contract with Amazon, it changed the game, changed everything. Because now all of a sudden, we could bring people together and we could host this on a common platform. We're being told across the government now, across the Intel community, let's all move to a common infrastructure, which is great. So people started thinking about that. But then we got back to the same issue. Okay, well, I'm just going to go rehost, virtualize my applications, rehost it, and recreate the same exact problem, right? Only thing I did is I consolidated my infrastructure. I provided some better standards, right, about how I gain access to a database as a service, maybe, how I gain access to like IAM. So there's policies in place, which makes it a little better. But it doesn't do what we really need. And so we had to create, from scratch, EasyBake. And EasyBake was our solution to make the government's life easier to transition all of these applications onto Amazon. And the first thing we did was we recognized we had to be technology agnostic because for some reason people like Ruby, I don't know why, and some people want to write everything in Python, and some people are Node folks, and we just found that it was a mess up front. Everyone had their own things, and we had to ease that. The second thing we realized was people wanted to be able to use whatever database they wanted. And God love them for it, but that was another key aspect that we had to answer. And then lastly, what we realized was batch and stream processing had to be abstracted, mainly batch. And the reason is when you're executing 5,000 MapReduce jobs at any point in time, and there really isn't good scheduling or management around that, things don't go well, ever. So we had to abstract that out. And then the other thing we had to do across the ecosystem was, how do we actually build in real security? How do we ensure everything's encrypted in transit? How do we encrypt everything on disk? And oh, by the way, every single object that is inserted into every database has to have a security control on it at the object level. So that was our standard. And that's what we built in here. So the first thing we did was we recognized, and this is actually, believe it or not, I came up with this listening to Werner Vogel's, his little speech when he was talking in Germany. And the epiphany hit, lots of alcohol was involved because we thought we were screwed. But we realized up front is that we had to build a data layer to be able to control this, right? So we had to abstract the databases. We had to abstract the way you brought data in, the way you stored data, and the way you got access to data. And by doing that, what we could do is lay down the initial fabric. So we'd create a massive VPC, with all these AMIs. We'd load it all out. We'd puppetize it, drop in and lay down the fabric. But then by laying a data layer on top, what that did was all of a sudden now we could just say, hey, here's a multi-tenant database. You as a developer, stop thinking about your physical model, start thinking about your logical indexing model, right? Start thinking about how you're going to store time and space versus how you're going to model your data in Cassandra or model your data into Elastic. Don't worry about that. We'll provide the scale, we'll provide access, we'll guarantee that, but you build your indices to support your application. The second thing walking up but how do I find data? The other problem was, remember the SOA issue. Everyone's trying to hit each other's APIs. What we realized was, well, let's abstract that out a bit. And so we modified the back end of Impala with Cloudera. And what we did was rather than utilizing straight HBase or HDFS. What we did is we hooked that into our data layer. And what we did is we built something called distributed query. And the idea behind distributed query, which I'll go into in a second, but is that I can now dip into indices if an application engineer will allow me to. And what that does is now, through a single API, that is guaranteed not to break. So even as we update it, the front end doesn't change. It's just the back end hooks that will change as we update it. And then with batch, we had to build, we realized up front actually the problem was in Afghanistan when we got to this problem. And we had something called green on blue. And what green on blue is that we had Afghan soldiers actually coming onto bases and killing coalition forces. Right? These are supposed to be our friends, and all of a sudden, things go horribly AWR. And what we realized is, one, batch processes are very slow to build. It takes, let's say, 3 weeks to build a job that you want to look across your data. By the analysts actually looking at patterns, feeding it to an engineer, and building it all, it was taking 8 to 10 weeks to get into production. So we had to build something, one, that makes writing MapReduce easier. Two, is we figured crowdsourcing was better. How do we build more efficient algorithms? And so we had to build a batch interface called Amino that I'll actually demo today, going through a London Olympics use case. And then the last thing was stream, ETL obviously is really important, data triage. We were finding that other than laying down infrastructure, the rest of the time of all these applications, all they were doing was prepping data. And they were rewriting each other's parsers over and over and over again. I don't know how many people have written a parser for Twitter in the US government, but it's absurd. So it's just over and over again. I'm like, it's really not that hard. So it's sharing code. And that was the key thing. So why don't we reuse each other's processors? Why don't we have like a marketplace where I can just go and look for each other's code so I can just plop that in, execute it, and run? And so these are some of the key features that I talked about. And I think that the most important that allowed us to transition to Amazon faster, and why we're getting the speed where we're actually migrating 3 to 4 applications a week right now. And we've just deployed on top of Amazon successfully in a pretty large cluster. It's really the security, the ease of deployment, and the ability to federate out that query through a single API. And by doing that, that completely changed the model where application teams were taking 6 to 8 months to get into production, now can execute and build or rebuild a small application, and we're getting into production in 8 days. And so when you think about 400 applications, the cost of that is significant in which we're saving. So I'm going to go through some of these key features, and I'd just like to get to some of the demo items so you can really see, the actual software versus me just talking through this. But the first thing I'll go through is the deployment model. So what we did find is that getting started was a huge undertaking. What we were seeing that was the average engineer in the government to get started on a project was taking 3 to 4 weeks. They start setting up their systems. They get their local dev set up. They sit down and look through APIs that they need to build. They start designing, right? It's way too slow. Our goal was, how do we speed that up and get them writing code within 24 hours? And so what we did was we built a local dev kit just using like Vagrant Box and pull that down. We exposed all the APIs on there. And what that enabled people to do is kind of like the Heroku model where you export out a build pack and then you just have your YAML configuration file. By setting up this model, that was the first real kicker was I no longer have to go deploy a database. I no longer have to go set up my web tier, right, and provide elasticity. I immediately just get that out of the box. I build locally, and then I'll go into this GUI. In this GUI, I can register my application or my service or my data feed. I can bring that all over, and it will automatically deploy in the environment for me elastically. And so the PaaS tier is we're using Kubernetes. So we're moving over to Docker, fully Dockerized, and utilizing containers to be able to provide security as well as resources. So the first thing I'm going to go is show you. And so you can see just a basic web application. And this was so key for us to just speed up. And we would just, test. But you're going to see some really weird stuff like US government. But then the other is authorizations. So again, in the US government, we are really, really good at making security really hard. And the idea is that anytime I deploy anything, I need to have security credentials around it. It's not just the data, right? I need to be able to secure an application. I need to have rights on a service, any analytic. I need to be able to know who has authorization to use this, and then not just deny them. Let's say I only have a top secret clearance. Well, if I have, let's say, other markers, it gets more complicated. It's not just like a couple little features here. It's also dissemination controls. We have all sorts of fun stuff in here. Non-IC markings. So we have thousands upon thousands of caveats that we have to handle. There's one object that I found that is just a piece of data stored where we had over 4,800 different caveats to be able to gain access to that one object. So meaning I had to be read on to all these different programs to allow me to see that one thing. And from a computing perspective, imagine trying to manage that at scale and on demand and still get sub-second response times, right? And having to build this into every single database, every single app, every single service. And so, sorry, wrong computer. And then also disseminations, like, because we do want to work with our partners. So adding in different countries. So these are the things that we have to make simple and easy right out of the box. Just deploying out software is not okay in the US government. We need controls around this and a nice, beautiful, easy to use GUI to allow our accreditors to feel comfortable about all this, right? And it's getting back, let me get out of here. And it's not just applications. How do I add data into the system? So do I have, am I listening to a pipeline or am I adding new data into the system? This is the distributed query. What am I authorized to dip into? What other sources of data do I want to gain access to? All of these have to have a workflow and a business process built in to allow people to gain access, one, to the application, but then also to gain access to other people's data or other people's services. And it all has to be fully automated and managed through a business workflow internally through a GUI. Because that's the biggest thing in the government we found was get out of command line, get it into some sort of user interface that someone can just click a button, they get an alert to their email, they go in there, they check it. Process is what slows. I mean, you've all been to the DMV. You see how slow it is there, right? It's much worse, trust me, in the Intel community. So you got to make it as easy as possible and as efficient as possible for the government. So then the next thing is, switch back over. Is collaboration. So another thing that, and I think we're going to see more and more of this is that, oops, wrong. There we go. Collaboration becomes really important. How do you reuse code and share it across different applications? How do you set up an environment where I can see what other people are working on? How do I operate like an open source project? And that was really important for us to help the migration on top as well. A lot of people didn't understand, like when they started talking about, like, well, what is RDS, or what are all these services that Amazon's offering? How do I gain access to some of that? They had they didn't even know where to start. But most of it was already done for them. They just didn't realize it. And some of it was on the open internet, which we couldn't use, so we have to pull it onto a unclassified but FOUO, enclave to allow them to work on it and pull that code in, right? So again, a collaboration becomes so critical. And what we did is we just created a simple little GUI. There we go. To get started. So like the first thing is just hello easy bake. How do I get started? And just getting this all on the web. And by doing this, people could just literally copy and paste. They could pull down that Vagrant box that I talked about and start writing code, but it's all set up for them. So like getting started on like how to bring data in, and it's all available. But once I actually know what I'm doing, then it's also starting to share like common services. Like you guys probably have no clue what a selector is. A selector is a unique ID that it can be associated back to a person. So in this case, we're extrapolating things like phone numbers, email addresses, IP addresses, et cetera, et cetera. And then not just extracting them, but also normalizing them. How do I get with a level of confidence that it's associated with a certain country, or et cetera. So I don't want to rewrite that algorithm, right? Someone already did that for me. So why don't I just copy and paste that, put that in there if I want to leverage that and run it, right? But then I want to maybe contribute to this. and I should be able to just go in there and do a pull request, right? That's really easy in the open world, but in the government, that is a novel concept of actually contributing to each other's code on separate projects. That does not occur often. And that was another huge issue for us, was how do we start to create that type of collaboration? And now, through this movement, what we found was applications were speeding their migration solely just by adding a stupid little GUI that allows them to find other people's code, you know? I mean, just launching GitLab and then just building a GUI around telling people, hey, go search for a service. It was that simple, but then people started to think differently. Engineers started to think differently. Was, hey, I'm not going to write this from scratch, which was, you know, that was the first step everyone thought of first, was that now thinking, oh, hey, let me see what's out there, then reuse that, right? But then we're like, okay, well, now people could get started. They're moving real fast. And then the next step hit. Okay, I can get my application team running. I know where to find all my code. I'm running in there. I've got an environment where I can build and deploy. It's all managed for me. This is great. Okay, well, how do if my application is constantly changing and there's the world around me is constantly innovating, you know, is Amazon, the question I always got, is Amazon, what do they have for NoSQL? They only have DynamoDB. Or like, when's, you know, RDS going to be available? Or, you know, what are all these different databases? In the government, we see that everyone loves databases for one reason or another. And so this is where the data layer came in. We had to kind of like create like a modern ODBC, right? Where we could just say, how do I abstract out all these databases and connect it in? And by doing this, this is really where you could do some really cool things. And the first thing was that this is where we inserted that method for object level security. So for each of these databases, like with Mongo 2.6, with HBase.98, we started working with vendors to get object level security built in, right? But at the same time, we can actually control that through our data layer. So if, you know, there's just a method to where you insert that classification control on that object, and if you don't do that, it'll throw an exception, right? So now all of a sudden we can actually control the standard of how you secure data at the data layer. And then what that allows in the next step is, and this is where like the Palantirs and the Tableaus and all the BI tools start to love us, is because, well, now, all right, now I have all these logical indices, right, of how I store either unique mission data, like I'll key on, I don't know, some guy's, you know, information, like his phone number or something, right? But now I've got all this other stuff, and it's not just text, right? It could be like a fingerprint, which is a WSQ file, right? How do I dip across and find information across specialized indices without having to write to custom APIs? So with the distributed query, I can dip in, and let's just say an easy one, like person equals Matt, and I can federate out and query all these indices. And this data layer is not, it doesn't have to be in this, like for instance, we have multiple different VPCs that this can run across, or this can dip in, which is really critical in a hybrid cloud use case. We have this platform now running on OpenStack, VMware, Bare Metal, and Amazon on AWS. And we can run that query across all different instantiations as they are migrating their capabilities onto a hosted environment, as well as when they're migrating off legacy databases as well. So we can go into production, we can gain access to that data, just lay the data layer on top, and ease them onto the modern IT enterprise, right? And that's been it's a huge challenge for the government to figure out, because they've invested so much money and so much time in all these machines and all these databases. To just move all over is just not possible. They can't do it. So they have to ease them in. And the last cool thing here is that we can dynamically filter out based on the classification control. So if I, Matt, have access to A, B, and C, and I'm using an application that can see A and B, and I use a service that can only see A, that query API will dynamically filter out and only present A, but then push out on there that for the developer to present to the GUI if they want, hey, but there was B and C, the user can see that, but there was restrictions based on the app and service. And all that dynamic filtering is all handled through that query API. And that's really where security becomes just a series of APIs. By introducing FRAC, which is how we bring data in, and we hit Kafka, which is a distributed message queue, and listening to those cues, we can apply security logic of who can listen to it. Remember on that registration page, who's authorized to listen and analyze that data, and then creating the method to which we can control how data is inserted into the database and who can gain access to that through the query API. Essentially, those are the three major tenets to then speed up the accreditation process. Where, like I said in the first slide, it was 6 to 8 months, and now an average application takes 2 days. And that there is how you migrate hundreds of applications quickly for the government. But then the last piece is data. How do I make data-driven decisions? And this is like where really, really the government is just lacking. And the problem is that they just haven't had the time to catch up to think, right? We've constantly been at war. We constantly need mission tools. The last person that gets told, hey, I'm a finance guy in the government, I'd like to make better business decisions, they'll laugh the guy or gal out of the room, you know? They'll just say, well, print more money, whatever, you know? No biggie. But now, obviously, it's an issue. And so we had to create an API, a series of APIs, that to deploy on top of here, we can actually monitor who's using the application, when are they using the application, how many errors is the application throwing, what data are they looking at, how often are they looking at that data. All that information needs to be simple. It needs to be 5 lines of code you can insert. It's like a Google Analytics, but specifically designed for government use cases. And so we have Swivel. There we go. And so the idea here is that we can easily go into an application, look at who's active in the system, in theory. Let's see. I need to refresh. It's another thing the government's good at. We have soft certs that will knock you out every 5 minutes. So the idea here is that we can look at users, we can look at the actions they're doing. Every single click is logged. So we maintain provenance on every action a user does in the system. And then we can also look at their sessions, so their pattern of life. And so we can actually then start building analytics on if they're outside. This is the Ed Snowden problem, right? So this is, are people trying to download things that are abnormal? Are people trying to gain access and do queries that are not normal based on their pattern of life or based on their role within the system? They're an intel analyst in a certain section, and this section is devoted towards looking at the Middle East, but they're doing queries in the Pacific. Why? These are the types of analytics we have to, but at the platform tier, as we migrate these applications on there, all we're trying to do is provide core services to be able to make that transition easier and get this as a service per se. And it's also errors though. It's not just the insider threat, but like where are they getting errors? How many errors are they getting? So let's just go back here a bit to all the errors in this app. So we can start charting errors over time. So yeah, the government's really good at dated browsers, like IE7 is still pretty popular, unfortunately. So we see when we're actually building modern applications, again, as teams are transitioning onto new infrastructure, it's all these other little tangibles that would slow them down. And so that's kind of like my pitch today is that if any of you are thinking about doing work with the government or trying to figure out how would I work with the government in this case, what we found was that Amazon was awesome, right? It made our lives so much easier to manage and to move capabilities onto the new infrastructure. But what we found was that it's the little intangibles that you're not thinking at a scale like AWS that slowed down the government, right? And so we had to fill those gaps through what we call EasyBake, a data productivity platform. And the reason is that we wanted to really focus on making application engineers and analytic developers productive by taking out a lot of the crap, like, you know, how do I manage my users and all that. But then the last piece here that I'm going to demo to you, in theory, if I don't get thrown an error. Oops. So this is the London Olympics. This is a fun one. So batch is hard. And so like people writing their own batch routines and asking questions of the entire data We've made all these other little intangibles easier. But now, all of a sudden, we found now, so this was, everything up to now, it was, hey, making applications is taking them, rewriting them, transitioning them, making them scale, making them easy to be on top of a distributed infrastructure, right? But now, all of a sudden, well, crap, I just created a new problem. And this is the problem we're facing, is they've got more time. And now they're actually focused on their business case at hand. So they want to build better applications, better analytics. They want to analyze more data than ever. And that creates this new mantra of, well, how do we correct that so 3 years from now we're not having to redo this whole thing again? And so with Batch was 1, security. So how do I secure all the data? 2, how do I make it so I don't have to manage like 5,000 MapReduce jobs at any point in time? And then 3, how do I crowdsource analytics because it's too slow to write common analytics that I can hook in? So in this use case here in the London Olympics, we need to be able to direct the police as well as other forces to specific areas in order to help predict, hey, there's going to be a drunkard and they're going to do something stupid there. So we're going to use a debauchery word, and we're going to use location, and we're going to do followers. And I'll explain this in a second. So the way this works is that we actually we actually do use a cumulo underneath the covers where we use iterators to scan. And then the idea here is that you write data loaders to this framework. And the idea is in our batch interface is that you can crowdsource people just breaking data down into its tiny little features. And you can even infer features from it, like sentiment analysis or whatever. Like obviously a debauchery word is not something that is in Twitter metadata, to my knowledge. Or location, for instance, because only 2% of Twitter is geolocated. But the idea is if we could just have a bunch of engineers infer information out of data and just load it all in, and then allow people, then pre-compute, so essentially create the mappers, and then allow a GUI to perform all the reduction steps and crowdsource those as algorithms and test them out. And so we first built this for that green on blue issue, and we ended up, through a series of iterations in 3 weeks, took out the entire network in northern Pakistan. And then we started to shift to different types of use cases, and to where we could actually now create a data science interface to where the common data scientists who had just more of an applied math background could actually infer information from this and then optimize their work. So we're going to go true here. So this is just indexing all the Twitter stuff. And then say Earl's volleyball court, because that's like happening. And then we want to make sure it's not a bot, because the Russians are really good at creating lots of bots and throwing us off our tracks here. So put more than 5, so we make sure it's on a machine. Oh, I got to name it. I always do that. And so we go from all these names in Twitter to, we can execute pretty quickly 24 names now. And then we can look at their distribution. And the idea is that this, can be a GUI for an analyst, but the idea is for an engineer, there's an API that I can hook into this. And you can see that because of the way we pre-computed and the way we compressed everything with bit vectors, it allows us to do very, very rapid type queries across very, very, very large data sets. So this is tens of petabytes of data. And that's really an interesting concept when you're starting to look at how do you do efficient batch operations across very large enterprise. And then for the data scientists, go backwards. What are all the unique variables of this person? And then perform the deviation. And then generate that query. And then find, in this use case, other similar people that meet that criteria, so shift it left and right. And then find, basically think of like origination theory with graphs, right? So going all the way, you got the source, let's start walking that tree and start finding who else is similar to that. So, obviously in terrorist networks, this becomes very efficient as to, hey, because you don't always want to capture the head honcho. I actually might want the middle tier dude who's more connected, right? Like a media emir in Al-Qaeda is much more connected because they have to deal with the videos. They got to get some money. They got to then take the video of the dude that's actually going to conduct the attack. They're connected. I want to go talk to that guy. I don't want to talk to the head dude who, only talks to 2 other people, right? It's that type of theory behind it. That's what we're looking for. So that's what the use cases around this stuff. So with that, oops, screw this up. The impact here is that, one, utilizing this model, rather than just native Amazon for the enterprise, where we had hundreds of apps, lots of data sources, what we decided to do is create a platform on top to abstract. So we still hook into RDS, we still hook into EMR, we still hook into all the goodness of Amazon. But what we do is just abstract those services. So as new services become available, we can hook them into existing APIs so applications don't break, so they can immediately take advantage of those capabilities. We added in security, so that way the infrastructure tier wasn't our bottleneck, in the sense that we could create standards of how we bring data in, how we store it, and how we are able to discover it. And by doing that, like I said, we cut down the time to migrate applications. We leaned up those teams so they could focus on their actual business case. We expanded the ability for people to discover data across the enterprise that was hidden. And then, of course, the overall, which for the taxpayer, this is great, right? We save the government money, so that's good, right? But most importantly to me, what I've seen through this transformational process is now we're getting better capabilities to our warfighters, which is saving lives. We're making better decisions. We're putting people in the right place at the right time, and holistically, that's what it's really about. And Amazon's helping us get there faster and better. So with that, if you want to talk to me, I'll be out there. I'm not that cool, but so thank you.